So we are starting with the geometry of the heat exchanger, and in the previous video we have modified the geometry of the heat exchanger. That is a shell and tube type of heat exchanger. And first of all, we started from this model, and we made some baffles here on the equidistance, and also we made the modifications in some errors in this geometry. And now we are going to create the number of baffles which are according to the heat exchanger standards, and that is to say that it should not exceed the spacing between baffles. It should not exceed the diameter of the shell. So right now, if you take a look on the shell, you can see that the diameter of shell is 40 millimeter. So it should vary from 0.4 or 40% up to the 100% of this value. So it shouldn't exceed the value of 40 millimeter. And therefore, I have placed the number of tubes is the same, but number of baffles here they are equal to, and number of baffles here are equal to 8. But in fact, that the first baffle and the last baffle, the first one is at the inlet and the last one is at the outlet. They are not considered to be the part of the formula. So this one we created is 8 millimeter from this inlet face on the right side, and similarly this is also placed at the 8 millimeter from this face, and this is the distance between the center of this is the distance of this baffle, the center of the baffle from the side of this inlet, and similarly for the outlet. And after that we will make the calculation for the distance between the baffles, and they all are placed at the equidistance, and for that we have to add the 1 in the number of baffles in the formula. So here the distance, that is the length between these two baffles, is equal to the overall value of the length of tube is that is from one side to second side inside the shell side is equal to 300, and so minus, just put the value minus here, minus. Now you can see that this is the distance of center from center of the inlet to the side of the shell equal to 15 millimeter, plus this is the distance of the half of diameter is equal to 8 millimeter from here to here, and plus another 8 millimeter from the side to the center of the baffle here. So 8 plus 8 is equal to 16, plus 15 is equal to 31. So minus 31 on the one side, minus 31 on the other side. So the remaining distance between these two baffles is equal to the 238, that is center to center distance of these two baffles. And if I divide this distance by the formula, that is you have to put the number of baffles which are remaining are the 6 and plus 1. So 6 plus 1, 7. So 238 divided by 7 is equal to 34. The distance between them is equal to the 34. So why 6 plus 1? Because now you can see here, this is the 1, 2, 3, 4, 5, 6, 7. So the number of passages here are 7. And number of baffles here, they are equal to 6. 1, 2, 3, 4, 5, 6. And therefore, because number of passages are equal to 7, therefore we have to add the 1 value into number of baffles, which is the 6 plus 1 is equal to 7. And the distance we are getting from baffle to baffle is 34. And that is the distance between the center of the baffles from each other. So they are the thickness of the 3 millimeter, so 1.5 millimeter on the each side of the center line. So let's do into the SpaceClaim. And again we are starting with this model, and this model is design number 2. So let me copy this in the SpaceClaim in the workbench. Okay, so basically we are working on design number 4, and in design number 4 we are basically adding the baffles into design number 2, and in design number 3 we have the 5 tubes, and in the design number 5 we will add the baffles also into design. So this is basically is a type of the full-fledged shell and tube type exchanger, but in design number 2 and design number 4 this is the tube and tube side of the shell heat exchanger. So this can be classified as the category of the shell and tube type exchanger, but this has the only one tube. So for this first of all, I can work from here. I can start working from here, and for that I have to remove these baffles from the model. So it's very simple. Just first of all, delete these baffles from the tree outline, second baffle and third baffle, and select these faces, these three faces which we used in the previous video, to move them to the required location, and simply use command of fill, and this will remove the baffle from the model. It's very simple. And again, fill command. The fill command has many options, many functions, and one of them is to fill the gap in the geometry. Okay, so I can delete this plane from the screen, and these planes are used for the dimensioning, so I will keep them as it is, and I will create the first plane. On the shell of this, the side of the shell. So this point can be assumed to be at the 0 location. So the first baffle is going to be at the 31 millimeter distance from this side. So the center of this baffle. So 15 plus 8 plus 8, 31. So I will just copy this plane. So Control C and then press Control V and then apply the move command, and distance is equal to 31 millimeter. Okay, and similarly copy this plane, Control C, Control V, and place this one at a distance of 34. So baffle to baffle distance after the first baffle is equal to the 34. So first baffle distance from the end of the shell is equal to 31 millimeter, and distance between the baffle, subsequent baffle, is equal to 34 millimeter. And similarly, Control C, Control V, and 34 millimeter. So this is the second baffle. So there are 6 baffles in between these two end baffles. Control C, Control V, 34. Again, same process. So I am repeating the same process again and again. So 1, 2, 3, 4, 5. Remaining one is the last one, which is inside these two end baffles. And after that, if you want to create a plane from other side or from this side, so the same thing will happen. But for if you make the plane from this plane, you have to make distance equal to 34. Otherwise, from this side, distance will be equal to 31. And that I can confirm by measuring the distance between this panel, this baffle, this plane, and this side of the shell. So from the pull command, we have the option for the measure, and the distance between this right side of the shell, this end of the shell, this plane should be equal to 31 millimeter. So just hold your control button and select these two objects, which is one is a plane and second is a curve on this end plate, and you can see distance equal to 31 millimeter. And now we can start working with our model here. And first of all, just move this plane slightly on the outside of this model here, and this can be placed anywhere, but it should be outside of this whole geometry. And you can hide these planes for time being. And once we work on this plane, that is here. So this plane will be used to sketch the primitive shape for the baffles, and using the combine command we can get the baffles from the shell, and then you can delete the remaining parts of that geometry, and then we are done with this part. So simply click on the plane view, and after that click on the sketch mode. This is very important. And then we are going to create the one line, that is from the any side from the bottom of this geometry. But only important thing is that just add a 10 millimeter from the distance of this line to center line. So 56 plus 10 is equal to 66. So that should be that when we split, or when we apply the intersection between this plate and the shell side, so the height of baffle should be equal to 30 millimeter, which is equal to 25% of the overall length. So the gap or the opening or the cut will be equal to the 10 millimeter, which is equal to the 10 divided by 40 millimeter of the shell diameter is equal to 0.25. So 25% cut should be there. This is the initial spacing we apply for the initial design in the shell and tube of the heat exchanger for the baffles. And then make the straight line, and it should be on the same line, but it can be of any shape, so it does not matter here, but the line over here should be straight line. So you can make these lines or this line as the inclined line. This will not make any difference in our overall geometry for the baffles. And simply click on the end sketch. Okay, now simply apply the distance of that is the thickness of this plate is equal to 3 millimeter. So this is equal to the 3, and this is the thickness of our baffles in this overall shell and tube type of the heat exchanger. So this is the 3 millimeter thickness of this tube here. And now we will start to copy these baffles on the geometry. So I will just enable these planes. Okay. Okay, from this master drawing, you can see that the first baffle is placed on the top side, and the last baffle is placed on the bottom side. So I will create these two models here. So first of all, I will copy this model. So Control C, Control V. And to select the body, when we apply the move command, we have to click 3 times in a continuous way. So just place this body at some distance from this initial body here. So there will be the 4 baffles on the top side and the 4 baffles on the bottom side. And this is the preparation for that step. And now we are going to apply the mirror command. And for that we need the middle plane here, that is over here. So this will be used for the mirroring this geometry. And so I can start with this part here. Okay, let me check the thickness of this geometry first. 3 millimeter, yes, correct. Okay, so this geometry is selected. Now you can apply the move command. So first of all, not the move command but the mirror command. So first of all, select this mirror plane, and then simply select the geometry. But before that, uncheck this option, that is a merge mirror objects, and second, create mirror relationship. So just disable this option here. And then from the select command, triple click on this geometry and delete the geometry from here. So now we are done with these two type of geometries. One is the baffle on the upper side of the heat exchanger, and second is the set of the baffle plates on the bottom of the this heat exchanger. So just move this geometry, the first one, to this plane here, apply move command, and use the option up to, that is you can press the U also from the keyboard and select this plane here, and this will place this plate nicely between the plane, that is half distance on the two sides of the on the other side of this plane here. And similarly place this baffle on the second plane, and then we will be applying the copy and paste command, and then we will place them on the subsequent planes here. So select this plate here and press the Ctrl C and Ctrl V, and then simply move this one on the alternative planes here. So we start with the upper side first and then on the bottom side, and this should be done Ctrl C Ctrl V and apply this up to and on the alternative planes here, then Ctrl C Ctrl V and then on the alternative plane here, and similarly on the bottom side triple click, Ctrl C Ctrl V, and again, so Ctrl C Ctrl V and then up to plane, so up to here, and again Ctrl C Ctrl V and up to here, and Ctrl C Ctrl V and again up to here. Okay, this is very important because if you take a look on this geometry here, this outlet is on the bottom side, so the flow should come in from here and then should go upward, so that this can have the contact with the flow with the coming from the tube. So in this way we can ensure there is 100% there is a heat transfer between the shell and the tube, and again it will go down from top side, so again it will interact, it will be in the contact between these two fluids, so this will make the transfer optimal. And now we can start with our combine command, and for the combine command I have just spread the one plate here, and we'll apply this command, this combine command, one by one on each and every plate, and in this way we will be able to create the baffles for all these 8 locations. So starting with the geometry, the target geometry is going to be the combine command is a shell, and the cutter body is the plate. And if you want to keep this baffle for the, let's say for the heat transfer applications, and usually speaking we will not keep this part here, so you can point this part and delete this part here, and this part can be deleted from the tree outline. So select this select option here and choose this solid body from the tree outline. Also you can triple click here and to select this body, and then simply press delete button from keyboard, and this will remove this plate from the remaining part of the plate from your geometry model. And now display this another plate here one by one and repeat the same process, and again I'm deleting this part here, and also choose the select option here and delete this geometry from here, and then choose the third plate. So this can be random number, so this can be the first, then fourth, then the first, third, second, fifth, but it doesn't matter here, because the only thing which matters here is that we are making the baffle at the proper locations. And again the combine command, and remove the remaining part from here, and now we can delete this part from here. Again the combine command and display another plate here for the baffle creation, and again delete the baffle from here, and again repeat same process, and another plate, And again we are applying the baffle command, the combine command on the baffles creation, and delete this part which is remaining, which is the outer side part of this plate. So inner was already deleted and the outer part of the plate was still there, and now it has been deleted. And then this is I think the last three remaining parts for the plates are there, and same process, and again delete. Now this is the last one, and delete the baffle from here and also the remaining part of the plate from the tree outline. And in this way we are able to create these all 8 baffles here, the 2 end baffles at the inlet and the outlet, and there are the 6 remaining baffles in between them, and there are the total 7 passages in between these 2 baffles. And I hope this will help you in understanding the SpaceClaim software, and also how to use this software to create the geometry of the shell and tube type heat exchangers. We will continue with this series, and we will come up with different models of the heat exchangers, so stay tuned.